All right, our next item, this is the gear problem in its full glory. We're given gear number 1, this is my large wheel, is gear number 1, radius is 5.1 centimeters. Gear number 2, the smaller, radius is 1.9 centimeters. Now, let's interrupt this. Everything that corresponds to gear number 1, I'm going to put a subscript 1. R1 is 5.1. R2 is 1.9. So now there's no confusion as to which R we're talking about. Whenever you have two circles, two gears, or two wheels, you should always subscript so there's no confusion as to which one you're dealing with. All right, so if gear 1 rotates 3 revolutions, so this goes 3 complete revolutions, the question is how many revolutions does gear number 2 revolve? Well, first off, it's clear they're not the same, right? In order for gear number 2 to do 1 revolution, the distance, right? Think of having a measuring tape. The circumference of gear number 2 is much smaller than the circumference of gear number 1. If this does 1 complete revolution, gear number 1 does hardly anything. But if gear number 1 does 1 complete revolution, all of this circumference has to go into this. Think of it this way. Imagine that gear number 2 is painted on the edge. As it makes 1 revolution, that paint comes off on gear number 1. But since this distance, this circumference is so small, it might only cover this much of the gear. Whereas this is much larger. So for each revolution here, this is going to make much more than 1 revolution. That's the notion behind mechanical advantage. And so the question is, if gear 1 rotates 3 revolutions, how many revolutions does gear 2 make? Now there's one principle that is absolutely important, and this is what makes the difference in all of these problem types. If you have 2 circles in the problem, if they have different centers, then the angles are different, but the arc length is the same. If they have different centers, the arc lengths are equal. And so, as this rotates, a certain arc length is going to be generated. The arc length of gear number 1 and the arc length of gear number 2 are equal. So if we have different centers, then the arc lengths are equal. Or, to make it official here, arc length number 1 is equal to arc length number 2. If the centers are different, the arc lengths are equal. Later on, we're going to consider a scenario where we have 2 circles with the same center. A different rule comes into play there. If the centers are different, the arc lengths are equal. So here's how this problem works. We are given the revolutions on gear number 1. So what I want you to do every time, in fact, I'm going to want you to see that. I want to see this on your solutions. The first thing we're going to do is, in circle number 1, gear number 1, we're going to convert from radians. We're going to convert from radians from revolutions. We're given revolutions. Convert from revolutions into radians. Right? Then, after revolutions, we're going to find arc length. But the arc length of the large is equal to the arc length of the small. So this is revolutions on gear number 1, radians on gear number 1, arc length on gear number 1. But that is equal to arc length on gear number 2. Then we use arc length of gear number 2 to find radians of gear number 2. And then we use radians to find revolutions. So we're going to start with revolutions on gear 1, translate to radians. From radians, we're going to find arc length of gear number 1. But because they have different centers, arc length 1 and arc length 2 are always equal. And then from arc length 2, we're finding radian 2 and revolution. So it's like we go down and then we come back up. Go down the ladder, come back up. All right? Now, this is the rough analysis. What we're going to do is this. We're going to start, and this is what you will write. Every time I have students solve these problems, if I've found in the past, if students write this down, it's almost hard to mess it up. If you don't write this down, you get lost. So always write this down. You'll see, you'll be glad you did. We're going to start with revolution 1 and use that to find theta 1. Use that to find arc length 1. That's equal to S number 2. Use that to find theta 2. And then use that to find revolution 2. Revolution 1, theta 1, then S1, then S2, then theta 2, then revolution 2. Remember, arc lengths are equal. Now, I'm going to want to see 3 columns. This analysis, and then the statements, and then the actual scratch work. So I'm going to get rid of this. I'm going to rewrite this now. So this is what your solution needs to look like. First, have that structure. Revolution 1 will find theta number 1, which will find arc length number 1, which is equal to arc length number 2, which will be used to find theta number 2, and that will be used to find revolution number 2. If we had 9 of these circles, you'd be finding revolution number 9. But we only have 2, so we're finding revolution number 2. Now, the next piece is we're actually going to write these values. Revolution 1 is 3. We're given revolution 1 is 3. We need to find theta number 1. So you're going to write your solutions here. Go off to the side and do the computation. How do we convert from revolutions to radians? 1 revolution is to 2 pi radians, as 3 revolutions is to, don't know yet, radians. 1 revolution is to 2 pi, as 3 revolutions is to, we're going to find this out. And if you work that out, you generate, so what do we do? Cross multiply. Theta is equal to 2 pi times 3, and that works out to be 18.8495. Yada, yada, yada. So keep that number in your calculator. Keep that number in your calculator, but write it down here. 18.8495. Use that to find S1. This is theta 1. We know S1 is equal to R1 theta 1, which in this case is R1 is 5.1 times the 18.8495, yada, yada, yada. Remember to leave that number in your calculator, and then multiply 5.1 times the number you have in your calculator already. And I believe that should give you 96.1327 and more decimal string. So what we just found S1. So that implies S1 is 96.1327 and so on. But S1 and S2 are the same. Because the centers are different, arc lengths are equal. Because the centers are different, arc lengths are equal. So this is equal to S2 is given by also the same number, 96.1327. And now we're going to use that to find theta number 2. Now, of course, you would just continue on your paper. I'm running out of space here, so I'm going to erase this and continue on my space here, because we have S2 is equal to R2 theta 2. And we're trying to find, we know what S2 is. That's the 961327. The number we have in our calculator is equal to R2 is 1.9. And theta 2 is what we're looking for. We know that because we're just following our little method here. We found theta 1, we found S2, we found S1, we found S2, now we need to find theta 2. So divide both sides by 1.9. 96.1327 over 1.9. Leave this number in your calculator. Divide by the 1.9. And if you divide that by 1.9, where's my number divided by 1.9? I have 50.5961. Yada, yada, yada. So that's 50.5961. Extending on out. All these intermediate results are left in your calculator. Because now the last thing to do is to convert that into revolutions for gear number 2. And the revolutions for gear number 2, again, I'm running out of space. You would just continue on your paper, but I'm running out of space. So 1 revolution is to 2 pi, as we don't know how many revolutions are to 50.5961 and so on. Cross multiply. So 2 pi times x, multiply this way, is equal to 50.5961. Divide both sides by 2 pi. But remember what we need to do? When you divide, you must divide by parenthesis 2 pi. And so we've left that number in the calculator. You always leave all these numbers in the calculator. Don't clear. And so that value works out to be, and finally, at the very end, round to, what did I ask for here? Round this to 2 decimals. Your last value, and only your last value, is 8.05. And that's revolutions if you want a unit. I want to be very clear on this. If the only thing you give me on the exam is 8.05, you are not getting much credit out of me. I'm not interested in the final result. If I wanted the final result, I'd go find it myself. It's not like I woke up one morning and so I wonder what the answer to this question would be. Maybe I could have my students help me. No, that's not what happens. What I want to do is to see if you can generate this logical flow. So your task needs to be create this logical flow. Every time you do one of these problems, do this analysis, write it out. Then you have this middle piece where you're stating the values that you're finding here. And then over here on the side are your computations. Now, I'm running out of space, or I'm just erasing each time, but each of these should also be neatly done so that anyone who looks at this can follow your logic and make sure that you understand the process that's being worked. So, what we'll do next is I'll go through another example of this. It doesn't take quite so long if you don't explain it while you're doing it. So we'll go through another example of this in the next video. This problem is very straightforward. It's very commonplace. So this needs to become part of your skill set.